So in our next section, we're going to look at the configuration of multiple context mode. We're going to take our previous design here where we have the ASA with 3 interfaces. We previously had inside, DMZ, and outside. And we're now going to separate these into 2 separate contexts that have unique inside interfaces, but that are then sharing the same outside interface. So from a logical configuration point of view, we're going to have context A that goes to router 1. We're going to have context B that goes to the test PC. And then this is going to be the shared outside interface that we're using to get to the rest of the network. Like behind router 2 would be the internet. Now up to this particular point, the only change that I've made on the ASAs was to go to global config and say mode multi or mode multiple. So again, when we change into multiple context mode, this is going to erase the previous config. If you notice here, when it actually reboots, it tries to load the configuration commands I had, and it's going to get all sorts of error messages here because these commands are no longer supported in the system context. So we were previously doing IP SLA in order to do tracking of routing, but IP routing is not supported in the system context. You wouldn't assign an IP to system. Okay, also notice what it's doing here. It says it's creating the context admin. This is happening automatically anytime you switch from single to multiple context mode. Okay, additionally, we have a failover configuration from before. I'm actually going to just delete everything and we're going to start from scratch. So I'm just going to say clear config all. This is similar to doing a write erase, but it is, we don't have to reload. Okay, the other ASA, actually what I should have done is show run for the admin context first. Let's look at the show run on the other ASA. Normally we have this. Context admin, and the admin context is admin. Okay, with the config URL. So this, again, typically is going to be where the management is done. So let's say here this is the host name now, ASA1, and it has the admin context, allocate interface M0/0. And the config-URL would be admin.cfg on the disk. So disk 0/admin.cfg. And actually, let's do this. Those error messages were because that file existed already. If we dir disk 0, let's say delete disk 0 admin.cfg. Then let me remove the context and reconfigure it. Show run context, no context admin. And then let's reapply it. Okay, next we're going to change to that context. Change to context. Here it does not give you context-sensitive help as to what are the context names that you configured, but you don't necessarily have to type the whole thing in. As long as you have a keyword that is not ambiguous, so the same as how the normal parser works in iOS or ASA, if it's something that you could normally tab through, then it's going to accept it. Now in this case, there's no other context configured, so I could simply say change to context A. That's the same as saying change to context admin. Because the letter A was not ambiguous, it was unique to match that individual context. Okay, so now we're under the admin context. If we look at the show run, basically the only thing that we have here is the management interface. So let's say on interface management 00, we have an IP address of 192.168.0.1. /24. No shut. And let's say we want to allow telnet from anyone. And that actually may be allowed by default. Okay, if we look at the physical topology, this management interface goes to port 12 on switch 1. So I'm going to go to port 12 on switch 1. Let's say no switch port, and I'm going to put it in that subnet. Let's say it is 192.168.0.100. And let's see, can I ping 192.168.0.1? Says the link is up down. What I forgot to do, if we change to the system context, let's look at that same output, show interface IP brief. If the link is administratively down in the system context, you cannot bring it up in the user context. So in system, you always want to make sure that you say no shutdown on the links. Okay, for simplicity, I'm just going to say no shutdown on all of them. If we now change to context admin, show interface IP brief, now it should be up, okay, which it is. It says the IP address is unassigned though. Why is it unassigned? Well, oh, it doesn't have a name. Let's say name if management. Security level 100. So can we ping it? Yes, we can. Can we telnet there? Probably not, because the link was down before. Okay, that's why I wasn't able to see it when I said telnet 00 question mark. Okay, management. And I need a password. Okay, so now we have remote access. In this case, we're telnetting into the admin context. The reason that I wanted to show this is that, again, for management of the physical chassis, the admin context is the one that you are doing that from. Now, it doesn't necessarily have to have the name admin. The key is that if we say change to context, actually change to system, I want to say here, and show run, it's not that the name is admin, it's that this name here, so whatever this variable is, has been defined as the admin-context. So this could say admin-context XYZ. It doesn't matter what the name is. It just means that this context is the one that you are allowed to issue the change to command from. So notice here that we telnetted in from switch 1. We log in, we're in the admin context. We can now say change to system. Or if we had other user contexts, we could say change to context A, change to context B. But from a remote access point of view, only the context that has this attribute applied onto it can then issue the change to command. Okay, so if you lock yourself out of the console, you want to make sure that you can get in remotely. That's essentially what admin context is doing. Okay, next we're going to configure the actual user context. So let's look at our diagram. And we need to know mainly what are the names that we're going to give them. So for simplicity, I'm just going to say A and B. And then also, what are the interfaces that we are going to allocate? So let's get out of the admin context. We need to go back to system. We're going to create context A and allocate the interface E01.115. Now, when we look at the options after this, it says we can optionally give it a name for mapping and then optionally define either the visible or invisible flag. Where you can see here it says that the default is that the hardware properties are invisible. So if I were to say allocate interface E0/1.115 as inside, let's also say what is my config URL. We'll say it's on disk 0a.cfg for simplicity. Then let's change to context A. Okay, context A, when we now look at the show run, it sees not interface E0/1.115, but it sees an interface that is named inside. This is what we're defining when we said, what's the interface name for mapping into the context? So in this manner, you don't need to tell essentially the customer that's managing the shared virtual firewall, they don't need to know how this maps to the underlying physical topology. So you can give them interface names that are inside, outside DMZ, and then just based on the name, it's self-explanatory what is that interface used for. So I don't need to know that it's 10 gig 0/5.185. So if you do not issue these mappings, it's going to pass the physical name to the context. Also, it says that the hardware properties are invisible. So if I look at the show interface inside, notice that there's no attributes here. Like I don't know the speed. I don't know the duplex. The only thing I know is that it's just an interface. Okay, on interface inside, I'm going to say the name is inside. And I need to, actually that's under, this error here is because of the system context. So let's say change to system. Okay, what I forgot to do first was actually define these sub-interfaces. So let's say interface E01.115 is VLAN 115. Interface E01.215 is VLAN 215. Okay, but again, that's a function of the system context because it's basically a physical attribute of the link. So let's change to context A. Now when we say interface inside and we give it the name if inside, and we give it an address, let's say 136.115.15/24. Now the underlying layer 2 configuration didn't change on the switches, so I should still be able to reach router 1 here. If we show run on interface inside, the logical properties are the same as any other interface that we had in single context mode. But again, if we look at the show interface inside and look at the attributes, we don't know the underlying physical properties. So we don't know what is the speed of the link. I don't know if this is gig or 10 gig. I don't know what are the CRC errors on the link, for example. Okay, that's what that invisible attribute is giving us. If we were to say for context B, we want to make those visible. So let's say under context B, we're going to allocate interface E00, and also we'll say that that's their inside, but make it visible. And we'll allocate interface E01.215 as outside. The config URL is, we'll say just b.config. And then for context A, we're also going to allocate that same interface. So let's show run context. This is what it means to have overlapping interfaces, that the same link is allocated to multiple contexts at the same time. If we now change to context A and show interfaces, we'll see that interface inside is, or actually not A. Change to system, change to context B. If we show interface, let's configure the interfaces. Interface inside is name if inside. Interface outside is name if outside. Because remember, all of the interfaces, regardless whether it's in routed mode, whether it's in transparent mode, whether it's in single or multi-context, they all need names and they all need security levels. So we could see by configuring the name if, it's automatically setting the security level. But if for some reason we didn't set both of these attributes, then you cannot actually forward traffic in and out it. Okay, if we show interface now, we can see on the inside, we know that the system name is Ethernet 00. This is what is the visible portion that I defined. So I now know what does that map to the underlying physical property of the chassis. Okay, there was a question here, can we set authentication per context? Yes, you can. We could do separate AAA configs. We could do separate local authentication configurations, which is the typical case that normally you would not have users that overlap between the contexts. You would have a super user that is for admin, and then the admin user is going to be able to manage essentially all of the contexts. But if I were to say here my password is Cisco123, that's only related to context B. Or if I have username Brian, password whatever, A, B, C, D, E, F, G, that's local to the context B. Okay, so next let's configure the rest of the addressing. So if we show run interface inside and interface outside, this is for context B we're doing. So on interface inside, our address is 10.1.0.15. On interface outside, our address is 136.1.215. And I'm going to say here that this is 215 for context B, and we'll use 115 for context A, because these have to be unique addresses on the shared interface. Okay, if we change to system, actually let's see if we can change, we should be able to change directly to context A, which we can. But again, this is only because I'm connected to the console as a user with privilege level 15. So if I was telling it into context A, I would not be able to change to B or change to system. So on interface outside, 136.1.215.115. Okay, next on the routers, I'm going to have to configure static routing, because one of the things we'll notice is that the OSPF process is now dead because ASA1 no longer supports dynamic routing. So as a simple solution for this on router 1, I'm just going to say for any destination, go towards the inside interface of the ASA. So 136.1.115.15. On router 2, we're going to do the same thing. So I don't care what the destination is. It's going to, and actually I'm going to need to do two separate routes here. I'm going to say to get to context A destinations, go to the context A address. To get to context B destinations, 10.1.0.0, go to context B. Okay, let's see, can router 2 reach these? So 136.1, 215, 115. And 215. Okay, it should be able to reach both of these. .215 and 115. Let's try this. Let's see from the ASA. Okay, right now we are in context A. Can we ping? And actually, let's show run interface outside. That's what the issue is. I didn't configure the name, which again means I don't have a security level, so I'm not able to pass traffic. So I'll always check this as one of the basic initialization parameters. That's the outside. Outside is going to be 0. Okay, so can I ping 115 now, which I can, and 215. Okay, so router 2 has reachability to both of these. So let's say for a little bit of further clarity, let me put these in different colors. So we have A here. A is .115 on the outside. And we have B. B is 215. Okay, next let's look at the actual traffic flows through it. Router 1 now has a default route to the ASA, which means it should be able to reach to router 2. And then router 2 is a default route back. So from a routing point of view, this should not be an issue. And from the ASA's point of view, if we show route inside context A, we have both of those links as directly connected. So we should be able to route between them fine. Okay, on router 1, let's now do a telnet to 136.1, 215.2, okay, which is router 2. Let's also try this from the test PC, the virtual machine. Telnet 136.1, 215.2. Next, let's look at, is the ASA dropping these packets for some reason? So in the system context, let's change to system. Let's turn logging on. And actually, I don't know, can we not log under... We can't log under the system context. We have to log under the user contexts. So let's say change to context A. Logging console 7. Logging is on. Let's change to context B and do the same thing. Log into the console level 7 and logging is on. Okay, can I reach the inside interface of the ASI? I probably should have tested this first on test PC, which it is. It's fine. So let's telnet through. It says I'm building an outbound TCP connection. I'm going to this address on the outside, 215 at port 23. If we look at the show connection, and actually this is under, let's say, show connection detail. It says the flags are lowercase s, lowercase a, capital A, where we are awaiting an outside SYN. And what's lowercase a? Awaiting outside ACTA-SYN. And capital A, awaiting inside ACTA-SYN. So what does this mean here? Let's look back at the diagram. It's saying that a connection came in this direction. It was the first portion of the TCP three-way handshake. Okay, the first portion is what? First portion is the SYN. Okay, the SYN went out to router 2. 2 should reply with what? should reply with SYN-ACK. So it's saying, I'm acknowledging that you wanted to start the session. I also want to start the session. ASA is saying, I'm waiting for this to come in. I never heard the return SYN-ACK. And additionally, I never heard the third portion of the handshake, which was the acknowledgement from the inside. So the first portion of the handshake is going out, but for some reason it can't complete it. It's basically a half-open session. But if we were to look at router 2, and on router 2, let's just say debug IP packet detail. Let's see, is router 2 actually receiving the telnet request from the virtual machine? Which it is. Okay, it says the SYN came in and we should be replying with AXIN. So we're saying we got your request to start the session. I also want to start the session with you. But the ASA is not receiving this back in. What would be the reason for that? Okay, let's look at router 2. When it goes to send the layer 2 frame back to the ASA, what is the actual address that it's using? If we look at the ARP cache, both addresses for the different contexts have the same MAC address. So this is the problem with the classifier that I was talking about before. It's not an issue with the flow leaving the ASA. The issue is that when it returns on the shared interface, it's coming in globally, and then the ASA1 doesn't know to send the SYN-ACK back to context B. Because it has the same MAC address, it basically the classifier just exits because it says, well, both of them are 8917, so how am I supposed to know? It just eventually throws away the packet. So again, there are three possible solutions for this issue. We can either give them different physical interfaces, so don't share the outside interface between the contexts. We could give them unique MAC addresses, or we could do the NAT translation. Now, by far the simplest of these is going to be to go to the system context and say MAC address auto. So automatically generate unique MAC addresses for every interface that I am allocating to a context. So now if we look at the, let's say, change to context B and show interface, these MAC addresses are now auto-generated from the platform. So they're basically like link local addresses. On router 2, if we now look at the show ARP, we can see now that the two next hops, the .115 and the .215, they have two different unique MAC addresses. So now the problem with the classifier should be solved. We should be able to send traffic out to 2 and then get a response back in. Same is going to be true on router 1. So router 1 now should be able to telnet to 2. So it's an interesting problem to try to troubleshoot if you didn't know that this was the issue to begin with. Because when you do a packet tracer, you'll see that the packet leaves and the packet returns fine, but somewhere behind the scenes in the control plane, the packet gets lost because it cannot make the decision as to which virtual firewall in order to send the traffic to, or which particular context. So again, you can use the other solutions. You could use the NAT translation. You could manually configure the MAC addresses. You could give them separate interfaces. But the way that I did it here, and let's say no login console, change to context A, no login console, change to system. If we show run, simply one command that's going to say for any interfaces here physically that are allocated to contexts, we're now going to give them virtual addresses. Okay, additionally, this class here, this is going to be how you limit the resources to the individual context. If we show context, detail, this is going to show you what are those specific limits. So here in this case, they are allocated class default. And let's see, does it show the details of show class? Let's say show run all class. Well, here actually this is all we need to know. It's saying for all resources they're not limited. So they do have the default class configured, but it's basically saying they can do whatever they want. Okay, if you go under this, you can modify the default one to say limit the resources for, the number of connections. But by default, it does not have a limit. So we can see here inside of the system context, the configuration is not very involved. We just define what are the contexts. So in this case, we have three. We have admin for remote management, and then we have the two user contexts, A and B. These are the interfaces they're allocated. By default, they are invisible, which means they don't know what does it map to underlying physically. And then where do we store the file? Okay, the other thing you need to be very careful of here is that now since these contexts have separate config files, when you write memory, you're not writing the memory of all of the user contexts. So when you are in the system context, you want to get into the habit of, instead of saying just write or copy run start, you want to say write mem all. So this saves the system context, the admin context, and then any of the user context. Okay, if we were doing failover, likewise, it would write each of these individually to the standby device. So you have to make sure that on a per context basis that this information is synchronized between the active standby failover pair. And again, we'll come back to that later to talk about the specific configuration of the active failover. Okay, there's a question: when you change to the admin context, does it ask for a password? If you are in the admin context, so let's go back to the switch. Okay, the switch, from the switch we telnet into the admin context. Okay, I configured a telnet password. I don't have an enable password, so I'm just hitting enter here. If we show user, actually, what's the command here? I need to look this up before AAA. I'm trying to figure out what is my local privilege number. Because it's not show a user, I'll have to, let me see if I can find it here real quick. Is it who? I'll have to look that up. But anyways, this particular user that's logged in right now has privilege level 15. So as long as they are authorized to use the command change to, there's no password to get into the system context. So it's assuming that you have already done authentication and authorization prior to getting into the admin context. Anyone in admin should theoretically have privilege level 15 because you're trying to give them chassis level administration privileges. So here under system, you do not go in and say that there is well, technically you can do this for local console authentication. So if I were to say like username, let's say username Cisco, password Cisco, username Cisco has privilege Username Cisco. I think that may be all we need to do here because we don't have AAA on. Then let's say AAA login. We can't do it from the system context. We're going to come back to this though. When we get to AAA, we'll talk about how do you do different authentication schemes for on a per context basis, and then the admin context and the system context. Because the system context, it would be your authentication and authorization to the console. But I believe that's going to be configured under the admin context because there's certain commands you cannot do under system. Okay, there's a question for routing. Is it global to the ASA or local to the context? It is local to the context. So here globally under the system context, when we show route, there are no routes because there's no interfaces that have IP addresses assigned to them. When we change to context A and show route, it has a routing table that is locally significant to it. If we change to context B and show route, I have a separate routing table. If we were to go to the VM here, the virtual machine should not be able to reach router 1. Not because they're being denied from a security point of view, but simply because they don't have any routes between the contexts. And if we were to check that from the packet tracer should tell us that the packet is going to fail because there's no route. So if we were to change to context B, and let's look back at the diagram here. So in context B, I'm going to say run the packet tracer, make it look like it came from the inside. Okay, on the inside, make it look like it came from the test PC. It's going to be an ICMP ping from 10.10100. ICMP type, was it 3? Well, it doesn't matter. Just say 00. The destination 136.1.115.1. That's router 1's address. Drop reason, no route to the host. So it is locally significant to the context, the routing table, and you have to configure them separately as static routing. I'm not 100% sure if version 9 supports this, but at least in our versions, there is no dynamic routing. If you say router, question mark, it's not supported once you move into multiple context mode. And someone mentioned here the command I was looking for was show kerpriv. Yeah. Because I'm local to the console at level 15, so I can do whatever I want to. Same as if I came in remotely, change to admin, change to context admin. Show current privilege. I'm at level 15. So level 15, since they are authorized to issue the command change to, you're implying that you don't need a password to move between the contexts. Okay, there's another question. Is it possible to shut down an interface per context even if it's up in the system context? Yes, you can. So you could go to the context, change to context B, interface outside, and say shut down. Now, even though this interface is shared here, the outside, me shutting it down in B only affects this .215 instance of it. It doesn't affect this one. So it's shutting it down in software locally in that context. It's technically not the same as saying shut down from a normal sense. So here if we show interface IP brief, from my point of view it looks like it's admin down, but only virtually under that firewall, not under other contexts. There's a question, how would you perform password recovery in a context? You would log in through the system or the admin context. So let's say we do this. Okay, we configure username, Brian, password, whatever, something we forgot what it is. Okay, so now when someone telnets into that particular context, and let's say this, telnet 00 inside. From the virtual machine, if we telnet to 10.1.0.15, the username is Brian, but I forgot what the password is. Okay, so I don't know how to log in. To recover this, what we would do is just get to either the console or to the admin context, change to context B, and then just say no username Brian. Because the key is that if you are already at privilege 15 in the admin or system context, you are inheriting superuser privileges to all of the user contexts. So it's similar to how Nexus does it. If you're a network admin in the default VDC, you can manage all the other VDCs. Or same thing is true with iOS XR. If you have admin privilege to the chassis, then you can manage all the other secure domain routers, the logical routers. So you would have to have whoever owns the chassis log into the ASA and then do password recovery. So you don't need to reboot the context per se in order to recover the password.